Although we can write simple tasks, as in this case, with statements following one another until we complete the task. Sometimes we have to group these statements together, such as this part and this part and this part in the middle, so that they serve a specific purpose. And in larger computer projects, it's not easy to maintain source code just by copying or replicating a group of statements just to display a square, a circle, or output something on the screen, send some sort of information over the network using the same sequence of source code, which might be several hundreds lines of codes or thousands of lines sometimes. So it's not a practical approach to replicate existing code and reusing that code. It is going to be very difficult. It's going to be very hard to modify those source codes in cases where the structure of the program or the requirement of the application might change. So there are some other cases which we are going to cover in upcoming sections that requires a specific portion of the source code to be grouped together, a specific portion of statements to be packaged together, and they're going to be evaluated with respect to some decision, some repeated instruction, repeated iteration, etc. And in order to do that, we need to know the boundaries of those areas that we specify for our blocks of code. What we mean by boundaries is that a specific portion of a certain behavior, certain activity, or certain data modification will start at one line of source code and it's going to end at another point. After that comes a different portion of the code which is not related to that specific behavior, which doesn't belong to that specific block of code. So in Python, we can delimit our groups of code by using indentation. Indentation is where we can simply add some spaces, let's say 3 spaces before each line. Okay, these 3 lines of code are grouped together, so they are actually inside this block started by some code block here. It's a statement. Okay, it's a hypothetical statement. It's not an actual Python statement, but it starts here and it goes all the way down to the statement line, which has the same indentation level as the first one. So anything in between these 2 lines of code belongs to the upper part of the code, which was started by some code here dash block 1. Okay, inside that block we have other source codes. The first one says that it states that the there's a code line, code inside this, inside block 1. This is the first statement of that block. Code inside block 2, second statement. Third statement has additional indentation, first for its own level, and the second one for those inside this inner block. Okay, this block belongs to this statement line. It is started with this one and it ends either at this point or at this point. So there are no other statements after this inner code block line. So it's terminated, the block is terminated by the outer statement, which is indented at the same level as the opening statement of this block. We will talk in more detail about these indentations, but it's a very important feature which is mandated by Python so that people can write more readable, more clear and understandable code. In other programming languages, you might encounter something like curly braces or other delimiters to specify the boundaries of these code blocks. But in Python, we don't have such a pair of curly braces, etc. We have this indentation rules that we have to obey in order to specify the boundaries of our code blocks. And when we move on, as in the previous slide, the indentation has to be equal sized, equally spaced. You can either use space symbols. Let's say if you start with 3 space symbols, you need to continue with the same amount in the same block. And in this source file, we don't have any indentation. Actually, we have 0 indentation. That all these lines of codes are going to be executed one after another. There's no grouping. They are on the main track of the application. But in the next example, we're going to discuss functions in Python. Functions, as I have been telling about the print function in the first stage. It is used by the Python interpreter to display some text. It is a built-in function. Or as you remember, we have turtle.forward, turtle turn right. These are also functions. The functions serve a specific purpose. In their internal design, internal implementation, they might have several other lines of code or several other library codes, function codes, but we are not interested in the internal details of those functions. So they are implemented, grouped together, they package some source code, and whenever we make a call to turtle.forward function, we know that turtle.forward is going to move our turtle pointer for a specific amount of distance in the direction that the turtle pointer is headed to. So we are not interested in how many stages, how many calculations the turtle library has to make. We just ask the library to move our cursor to a new location. So this provides some sort of encapsulation or packaging of internal statements. And when we write our code in functions, we all increase the readability and quality of our code. So instead of repeating all these 8 lines of code each time we need to make a square, we just simply define a function with the def keyword, which is short for define, and we specify a function name, we specify a pair of parentheses, and in between those parentheses we might have 0 or more arguments that are going to receive values from the calling statement, which is this line. In this case, this is draw a square for me 100 is a calling statement for the function, and the definition, the signature line, which is the first line starting with def, the signature of the function definition ends with a colon. This colon is very important. You shouldn't omit that. Otherwise, your program is going to raise an error. And within the function, we have a group of statements which we need to implement as much as required. And then each one of these statements have to be indented inside. Okay, they have to be indented inside. This has been a very large line, so they all have to be indented inside for about 3 or 4 units at the moment, 4 spaces. So if we look up the upper statement, it says def, 3 letters here, and the space, and after the space starts the first characters at each line. So there are 4 spaces used as the indentation level of this function block. So this is our function block, and then all the instructions inside this function body are executed one after the other as soon as there is a function call at this line. Here you can see it, and there's another function call, and there should be a third function call where you can see here on this final line, on the line before the final line. So we have actually 3 lines of function calls to the function definition. Whenever we define a function, it is not executed immediately. It has to be called from another line before it's executed. So defining a function, in fact, is defining a means of description to the Python interpreter. Python will know that there is something called draw a square for me. Okay, and the behavior of this draw a square for me is to move the turtle forward for a specific amount, which is provided as an argument. As you see in this argument, it says square size, and it's been reused in each one of these lines in the same way. So it's case sensitive. If the first one is, if the argument definition itself is lowercase, okay, wherever you need to use them, you have to specify it as lowercase as well. Otherwise, they will be treated as different values, different variables, etc. So it's one of the very important points of programming. In most cases, in almost majority of the programming language, you have to be careful about type casing. So if it is if there is a specific uppercase symbol in a variable name or a function name, you have to obey to the same format. In the rest of that code block, which might be a function definition or something else. So what is a function, or how it is defined? It first consists of a signature, and the signature itself consists of the function name, an opening parentheses, any number of input arguments. You might not have any arguments, but you still have to have the pair of parentheses, a closing parenthesis, and a colon. After the colon starts the function body. Okay, and inside the function body you describe how this function is going to make a calculation, how this function is going to behave, how it's going to produce some results, some shapes, some images, and how it's going to serve its purpose. So the function body is where we write our solution inside the function. But as I said earlier, once we define a function, it doesn't mean that Python is going to execute this immediately. Okay, it encounters this line and it knows that the def keyword means that Python is defining a function. It's learning how to execute this function, and it leaves it there. It's going to execute the definition. It's going to realize or materialize that function definition as soon as it encounters a line of code, such as draw a square for me. This is the function call line. So the first thing we do is we teach how it's going to perform, and then we make a call if it is necessary. If it's not necessary, we are not going to make a call. We don't call all our functions each time we execute our code, only if it is necessary. And here are some conventions about how you can write your source code, how you can define your functions. For instance, they are case sensitive, as I told you. You cannot interchange uppercase and lowercase letters, and you have to be precise about the ordering. And you can write it with underscores, and if you started programming in other programming languages such as Java, etc., there were conventions like a camel case, mixed case convention, but Python uses underscores in function and variable name definitions. So this is a more clear reading, if you put it this way. You cannot put any space symbols in between the function inside a function name itself. Okay, you can include underscores, but you cannot add hyphens or minus signs. You cannot add exclamation marks. You cannot start the function name with a number. You can have a number inside or at the end of the function name, but the first character has to be a letter from the alphabet. And the best convention is that your functions give some idea about what it's going to perform. So if you write function 1, function 2, function 5, etc., you will probably not understand the source code when you come back and revisit that code or try to maintain it, if you haven't included very precise comments on that function. So if you are going to specify multiple arguments, you need to insert a comma in between those arguments. You might omit the arguments altogether, but depending on the type of the function you are defining, you will most likely need arguments, more than one. So if there is such a case, you're going to split them with a comma in between each. And again, as a best practice, you should avoid functions that are too long. You might probably be able to split them into multiple functions, so you can handle them better. Larger, bulky functions will usually cause more problems when you are trying to fix or update or modify those functions. Okay, indentation, as we talked about, is the marker for starting and ending point of the function. And throughout your programs, the order of statements is important. You cannot change the order and expect the same result in almost each case, but it doesn't matter if you swapped these two lines with these two lines, because they are identical source codes. But if you swap this one and this one, okay, the order of execution changes, so the behavior will most probably change. Not for the last edge in this specific case, but in, let's say, in the middle of the square, if you swap these two lines of code, such as right and forward, it's going to move forward, and then it's going to move forward once again before it makes a right turn. And after moving forward, it's going to make two right turns, which is not our intention. So we cannot expect the code to behave in the same way when we change the order and structure of the statements. So when we run this example using the functions, which is very similar to our earlier turtle square source code, there is this function definition for us, but it's not executed immediately, although it is the first statement after the import directive. It's not going to be executed until it is called at this line. Before executing the function, we have turtle pen up function call, turtle go to function call, turtle pen down function call. These are all function calls, okay, to turtle library. Now we have defined our own function in our program. We can make a call to our function. We don't say turtle dot draw a square for me, because turtle itself does not have such a function. It's our custom function. It belongs to our program. The turtle library does not contain such a function name, so it's going to raise an error when you try to execute this code. Let us see. It has crashed that the module turtle has no attribute draw a square for me. So be careful. Although we write turtle all the time until now, it doesn't mean that from now on we can use turtle at the beginning of each statement. There's no such thing. We only use turtle if we require the turtle library to perform its own task. And at the following lines, we have these turtle pen up, backward, left, right. And from there, we have set a new color to the turtle program. And then we tell the turtle to draw another square, which is slightly larger than the initial one. And then we repeat these sections. Okay, there are 6 lines of code, as you can see. They are also identical. Let me highlight it for you. So this part and this part is also identical. So we might think of grouping those lines together and writing a single function, and that function can be called at 2 lines only instead of 12 lines, as in this case. So if we move on with the function, we can further define this part as I just told you. Actually, these two portions, my code has shifted. So let me clear this out first. So here's the implementation version of the idea. There is this function definition of draw a square for me. Draw a square for me. So draw a square for me. This is one function. And we have the second function, which is move turtle back. What we did is, whenever we complete a square, we move our turtle to a new location to begin drawing the other square around the initial one, and we started placing more and more squares around those inner squares. So each time we want to draw a new one, we have to move our turtle to the beginning point. So this code block here simply does that job for us. It moves the turtle's pen up, it lifts the pen up, and it moves the turtle backwards, turns it left for 90 degrees, moves forward for 10 units, again turns to right, and puts the pen down, just waiting there for a new action to be taken by the program. Okay, this is not part of the program. So these are two functions written in our code. If we try to execute this application with two methods, you can see here that there were 8 lines replaced by a single line, and there are 6 lines replaced by a single line. So not only we save some space, we also increase the quality of our code. So if we want to change the initial position of our turtle, for instance, if I want to move my turtle back and make a circle at that location each time I execute my drawing, it's going to make this circle and start drawing the new square at that position. So this is the change of behavior at one location. I have changed the behavior at one location. The effect takes place at more than one locations. Let's count 1, 2, and 3 locations. Okay, I didn't have to go to 3 different places and change these lines. If you think of it as 3 lines, it's simple. But if this function is being called from hundreds of different places with different variables, it will not be very easy to go and maintain them. Also, whenever you code your application or library, you might be shipping it to somebody else, which in this case is the turtle library. We are using somebody else's code. In this case, somebody has written it for us and we are using it. We know that when we want turtle to move at a specific distance, it's going to make that move. But at some point, the behavior may change. The internal structure of this function set may change. But we don't have to know about the implementation details. So if we had to replicate Turtle's code to make simple lines or change colors, we would have to do that change in our own code as well. Okay, if we had to replicate whatever is present there in our source code instead of using functions, we would have to alter the behavior everywhere we implemented that solution. So encapsulating these or packaging these source statements, source code lines together allows the maintenance or modifications to be easier. If our purpose is to keep the present situation, but make a new version, then we are going to have to either use some arguments or some other functions for that job, for both preserving the old and moving with the new versions of drawing a square or moving our turtle to a new location and drawing stars, circles, etc. before we start the actual square. So we have many turtle move back calls, 1, 2, 3 calls, and we're drawing 4 squares with less lines of code than the initial versions. So if we have drawn 4 squares with code replication, copy paste, our code would be much longer and much harder to maintain. And we can also add more functions to our code. As you can see in this previous example, we have set a turtle pen color. Sorry for the thickness. So we have set a pen color. Here we tell this turtle to draw a square and move the turtle to the beginning point of the next square, and this is also repeated. So these 3 lines of code are also repeated. We can group them into another function and make calls to that function call, as in this example here, which is drawing a square and moving back. The naming of the function has nothing to do with the internal statements. So it's just for better readability. It should give a clue about what this function is doing. So it doesn't mean that draw a square and move back doesn't imply that it's going to first execute this draw a square for me and then call the move turtle back function. It does it only if we tell that function to behave in that way. How do we do that? We write our statements. We first tell the turtle to draw a square for us. Okay. And also the Python doesn't understand natural language if you don't use some specific libraries. It doesn't know from the context of the letters you are organizing as your function names. It only cares about what you have defined and which order you are calling them. So we have defined this function up here with the name draw a square for me. I could have given this function the name chair, for instance. Okay, it would be chair, and I would write chair down here, and it would still execute the same code which is 8 lines of moving forward and turning right. Okay, whatever you define as your function name, you will have to use it in the exact same ordering of letters and numbers and underscores. But if you expect Turtle to or Python to understand your natural language, you will have to improve more on this natural language processing libraries or artificial intelligence libraries, etc. So this is out of the scope of this course. So we're just dealing with basic stuff for the time being. And if time permits, we are going to discuss about them a little bit. So I have grouped my code, which was turtle pen color, draw a square for me, move turtle back, 3 lines of code. Now instead of 3 lines of code, I can make a single line of function call, draw a square and move back with the arguments red, as you see here, and 100. It means that the first square is going to have the color red and its size is going to be 100 units. Its width is going to be 100 units. And the second square is going to be using blue color and it's going to have 120 units of width. How does the program achieve this task? It's first going to call this draw a square and move back function by setting this square color to this first parameter here. This is the first argument to the function. The order of arguments is very important, just as the order of the statements. So the first arguments, regardless of its human readable form, it is the square color. The second argument is the size of the square, so I can use this first one to call my turtle.penColor function, which we initially called like penColor blue, penColor green, penColor yellow, etc. We were specifying them explicitly. Now we are receiving them as arguments to our function. They are replaced by red first. In the first attempt, the square color is replaced by red. Okay, and this one is also going to be red because it's the same argument. And then turtle pen color is going to be called with the value red. And in the second iteration, the pen color is passed as blue. Okay, the square color is passed as blue, and that square color is used as the pen color argument, and turtle is going to set its color to blue as we did manually in this part here. And the second argument is the size of the square. The size of the square is required for draw a square for me function, which we have defined. It's not in the turtle library. And if you move up, it receives this argument that we already have provided. And it receives a square size, which is going to be either 100, 120, depending on the statement line. And it's going to place these values into each lines in the exact amount of distance. And there, our turtle is going to make equal movements on line segments and turn 90 degrees. At the end, the application does not know anything about a square. It just knows that it has moved from some location to another location. It made some turns. It changed its orientation. And at the end, we perceive the result as a square, but there is no such thing as a square in the library's mindset. Okay, it's not an entity. It's not a being for that library.